let's talk about another thing that an attacker can do with services to maintain persistence. And to illustrate this one, I want to examine one service file in particular, and that's the one for SSH. If I go to etc systemd system and I print out sshd.service, this is the service file for SSH. But you'll notice something interesting about it. Along with this execstart, it also has an ExecStartPre. Sometimes before a binary gets run or before a service gets run, it needs to execute some other sort of commands to prepare the system for running that service, or to prepare our machine for running that service. How can we abuse this idea as attackers? So we know that in certain service files, like for example the one for SSH, we can use ExecStartPre to run some command before the service is actually started. Well, this means that as attackers, we can pick any service that's going to start on boot. And what we can do is we can add this ExecStartPre to the file that's responsible for that service, and then we could have it run whatever malicious thing we want to run. Again, that could disable firewalls if we put iptables-f, remember that thing that I showed at the beginning, or we could run that payload that causes it to connect back to us. So again, this is another one that requires root privileges. So we're going to assume for the sake of this demo that I'm root. And let's just backdoor the Apache 2 service. So let's say we compromised a web server. It's running Apache 2. We know that somewhere on the system, somewhere here is going to be the Apache 2 service file. So if I go system control status Apache 2, we see that Apache service file here. So I'm just going to go ahead and copy that. And I'm going to go ahead and edit it. And then here, before exec start, I'm going to add an ExecStartPre. And then I'm going to set this to run my malicious payload. So in this case, if you remember from before, I stored that at bin payload. And the last thing I have to do is I have to make sure that that payload file is runnable, because when I was on the defensive side of things, I made it so that I can't run it. So I'm going to have to actually reset the permissions on that. It looks like I actually removed it completely. Silly me. So I'm going to have to upload it again, but that's fine. I'll upload it the same way I uploaded it before. So it looks like that payload file is there now. We uploaded it. And in that service file for Apache 2, if I print that out one more time just to show you, I added this ExecStartPre so that whenever Apache starts, our payload is also going to get run. And that's going to cause the target to connect back to us, the attacker. So again, since I made a change to a service file, I'm going to have to run system control daemon reload. And just to test this out, I can actually now go ahead and restart Apache. And this should actually go ahead and restart Apache, but along with restarting Apache, it should reach back out to us and connect back on Sliver, right? So if I go system control, restart Apache 2, you'll notice that it's hanging. And if we go back here, we did, in fact, get a connection. However, the problem here is that it's hanging. Why is it hanging? Well, because the way ExecStartPre works is it actually waits till this command is fully finished running before it runs execstart. So we're going to have to do something so that this actually runs in the background. And so it can continue running even when we run Apache CTL start. Okay, it took me a little bit of playing around with it, but in the end, I solved my issue like this. If we take a look at our Apache 2 service file here, what I did is I actually had it run a script. Now that script itself exits. So we don't have to worry about that script hanging. It'll just run that script will complete, and then it'll start the Apache service. What does that script actually do? Well, let's take a look at what I put in that script. So if I print out my little script here, which I called helper.sh, this script just starts bash, and it runs my payload in the background. So there was no way for me to run my payload in the background using ExecStartPre, but what I could do instead is I could run this file in bash, and then through this file, run my payload in the background. And you'll notice, now that I went ahead, I did the daemon reload, and I restarted Apache 2, if I go back to Sliver here, I got this connection back. And I can actually connect to it by saying use, connecting to it, and I can use it and run commands like ls or pwd or who am I? And the neat thing about this is if the target were to reboot their system, again, it doesn't matter, because once that system reboots, or once that target reboots, it'll reach back out to us, and we as attackers will still have access. So I can demonstrate that by rebooting the target. So now I lost my access here. If I try to run commands here, they're going to hang forever and they're never going to run. Right? And then I'm going to fast forward to when the machine reboots, and I'll show you that we actually received a connection back to our attacking machine. Now that my machine has rebooted, you see that I got a beacon back. And if I try to interact with it, you can see that, again, I can run commands on the target. Back on the defensive side of things, this one is a lot harder to spot, because if we go ahead and take a look at what services we have on here, we won't see any that are out of the ordinary, right? We only see our normal Apache 2 service, which we expect to be there. So what's one way that we can go about actually identifying this attack? Well, this is why not only does it make sense to look at services, but it also makes sense to look at processes. If I take a look at what processes are running on my machine, I'll print them out in a prettier way. So I'll say -EO to choose what I want to print out. I'll print out the user, the process ID, and the command line. Uh-oh. Sorry, that was my keyboard glitching out on me there. Then the other flag I'm going to add is --forest. And I like adding --forest because that shows me which processes are children or parents of other processes. So it'll actually make a tree of sorts whenever a process has children. You'll see what I mean by that in a second. So if I print that out really quickly, you can see that in this case, we have this user Espen Apache 2, and then all of these processes here are children of that process, which is indicated by that tabbed, by it being tabbed at the beginning there. So if I take a closer look at these processes, and I'll pipe this into more so I can go through them one at a time. These ones at the beginning, not super interesting. Nothing really going on there. Once I get past these are going to be the more interesting processes. We can see cron is running. We can see there's some login. There's actually us running this command. So that's pretty cool. And, oh, this one looks interesting. So you'll notice that right here, process 1437 stands out a little bit. What the heck has been payload? Well, if we dig into that further, we'll notice that that's some kind of custom binary that didn't come with our Linux machine. And thinking about it, we might guess that we don't need this running on here. Why is this running on here? So one thing I can do is I can kill that process and make sure that that didn't hurt anything, right? So I'm really pretty sure it's malicious. I'm going to try killing it. I'll say sudo kill 1437. Boom, that process is gone. If I were to try to list it again, this time I'll grep for 1437. It's gone. I can grep for payload. Also, nothing's coming up. So, okay, we contain that. The other thing we can do is we can make this file not runnable like we did before. So we can say sudo chmod 000 bin payload, and now that file is no longer runnable. Or if we're very, very confident that this file is not supposed to be here, then we can remove it. But again, I still suggest making it unreadable, writable, and executable rather than fully removing it, just in case you need to restore it later on. And then, okay, so we saw that bin payload was running, but we obviously didn't run it. So that means somebody else ran it. Either somebody else got on our machine and ran bin payload, or there's something on our machine that's starting bin payload. So what I would like to do is I'd like to search the files on my machine to see if any of them contain bin payload. So if you remember from a previous video, we used grep-H horn to search the contents of all the files in a specific directory. And I can actually use that to search for bin payload. So I'm going to say search for bin payload. And now what directory do we want to search? Well, we could search the root directory, but that would probably take a really, really long time, and it would search a lot of files that aren't interesting to us. So I would probably restrict my search to something like the etc directory, or the var directory, or the opt directory, or the root or home directories. Each of these are directories that contain files that could be potentially interesting to us, and that are very likely to be running this payload. So if I search the var directory here, it might take a while. I don't know how long it'll take, but in the end, we'll see if we find anything. So I'm going to stop this already because I know we're not going to find anything in the var directory. However, let's try etc. Nope, still nothing. Let's try /home. We actually do see it in users bash history. That's because I was working with it earlier. That's actually not anything super interesting. If we look in /root though, here we see that bin payload is referenced in /root /helper.sh. That's rather suspicious. Let's check that file out and see what it does. If I print out the contents of root helper.sh, well, would you look at that? That file actually starts this payload, right? And so that's interesting. So we have this helper.sh file that starts this payload. Now I wonder if that helper.sh file is called anywhere else. So we can do the same thing we did with bin/payload, but instead we can do it with helper.sh. So let's say search the root directory, nothing. I mean, I see it in the history. That could be interesting. I could check out the command history and see if there's anything there. I can try etc. Nothing there. I can search /home. Nothing there. I can search /lib maybe. That one's going to take a while to search. But aha! Here we found something. So if we look here, we see this apache2.service file, and it actually contains helper.sh. We also see a bunch of other files, but these are all binary files, so they're not too interesting to me. See how it says binary file matches? I could even use a second grep to get rid of the binary files and just keep the regular files. But in this case, I saw that file at the beginning there. So if I run this again, we see that first one there. That looks kind of interesting. Let's take a look at it. So if I print out lib systemd system apache2.service, aha, you'll notice this ExecStartPre here, and you'll see that it's running root helper.sh. So this is an example of how, as a defender, you can kind of work your way backwards to figure out the attack chain. So first, we saw that bin payload was running, and so we wondered what was starting it. And so we searched a bunch of files in the file system, and we found this helper.sh that was running it. So we're like, okay, well, then what's kicking off that helper.sh? So we searched the file system again for helper.sh. We found this service file, and we see that this service file is running helper.sh on boot, right? So then knowing this, I can make the necessary changes to undo this. Again, I like to keep backups of everything in case something that I do messes up one of my services or messes up scoring so that I can easily set it back. So I'm going to be very careful when I do this to make backups of everything. So the first thing I'm going to do is I'm actually going to make a backup of this service file here. So I'm going to say sudo cp, and I'm going to back this up to /lib systemd system apache2.back. That way, if I ever need to restore it, I always have it there. I can always restore it. Now I can go ahead and modify the service file itself. I can remove this ExecStartPre, save that. Now that I made that change, I have to do a daemon reload, right? So I'm going to go sudo system control daemon reload, just like that. The other thing is I'm going to go back to the root directory. So I'll switch to root to this because it'll be easier to work with it that way. And in the root directory, I have this helper.sh. I think it's malicious. I'm not entirely sure. So what I can do is I can change the permissions on it again to 000. Then nobody can do anything with it. The other option is to remove it completely if I'm sure that it's bad. And then last but not least, I want to actually remove that payload. So I can go to bin, and I can either set the permissions on that payload so nobody can run it, or alternatively, I can remove that payload altogether. So I can say rm payload. That is how we, as a defender, would go about removing this persistence mechanism. Looking back at our list of attack vectors, under persistence, you can see that so far, we covered the first three. And in doing so, we learned a lot of new Linux concepts. And it took about an hour of video content. That's a lot. And that's only a fraction of the different persistence mechanisms that exist in Linux. I, to this day, am still learning about different creative ways that attackers use to establish persistence in Linux.